We say the outcomes of an experiment are equally likely if all outcomes in an experiment have the same probability. For example, flipping a fair coin has two outcomes that are equally likely, heads or tails. Rolling a fair six-sided die has six outcomes that are equally likely, 1, 2, 3, 4, 5, or 6. If all outcomes in an experiment are equally likely, then the probability of a particular outcome is equal to 1 over the total number of possible outcomes. It follows from this relationship that the probability of an event is equal to the number of outcomes in the event over the total number of possible outcomes. Let's go through an example that shows why it makes sense that the probability of a particular outcome is equal to 1 over the total number of possible outcomes. Let's say that 4 balls labeled 1 through 4 are placed in a hat and 1 ball is drawn. Each ball is equally likely to be drawn. What is the probability that the ball labeled 2 will be drawn? The sample space of an experiment is a set of all possible outcomes. In this case, the possible outcomes for the number on the ball drawn from the hat are 1, 2, 3, and 4. This is our sample space S. Based on the rules of probability, we know that the sum of all possible probabilities must be equal to 1. So, the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 4 equals 1. Now, we also know that every number is equally likely to be drawn, so we can also say that the probability of 2 being drawn is equal to the probability of 1 being drawn. We can also say that the probability of 2 being drawn is equal to the probability of 3 being drawn, and that the probability of 2 being drawn is equal to the probability of 4 being drawn. With this knowledge, we can rewrite our sum of probabilities equation as 4 times the probability of 2 equals 1. By dividing both sides of the equation by 4, we get our solution. The probability of 2 is equal to 1 over 4. Remember that 4 is our number of possible outcomes. So, we see here that when outcomes are equally likely, the probability of an outcome is equal to 1 over the total number of possible outcomes. Let's go over an example dealing with the probability of an event when outcomes are equally likely. A box of rubber balls contains 3 red balls, 4 blue balls, and 2 yellow balls. If a ball is chosen at random, what is the probability that the ball is red? In this case, each of the balls in the box is a possible outcome, and the outcomes are equally likely. First, let's find the total number of possible outcomes. There are 3 red balls, 4 blue balls, and 2 yellow balls. So, the total number of possible outcomes is 3 plus 4 plus 2, which is 9. We want to find the probability of the event that the chosen ball is red. There are 3 red balls, so the number of outcomes in the event that the ball is red is 3. We know that with equally likely outcomes, the probability of an event is equal to the number of outcomes in the event divided by the total number of possible outcomes. Our number of outcomes in the event is 3, and our total number of possible outcomes is 9. So the probability that the chosen ball is red is 3 over 9, which can be simplified to 1 over 3.